All right, we have a couple of multiple choice questions, and my concern here is that whenever we see these, students tend to want to just sort of make up some sort of history of physics or something like that. And I can just guarantee every single question in physics that we deal with, every single one, there's always a way to kind of squeeze a calculation out of the problem. And these concept questions are no exception. So, for example, we have a rifle that recoils, which means it kind of has a kickback when you fire it. Um, and what we ask here is we want to know how the impulse of the rifle compares to the impulse on the bullet. So instead of trying to, what your brain's going to want to do is you're going to start thinking about bullets and rifles and which one's heavier and which one's lighter, and all of that is a bad idea. Instead, let's go into the laws of physics. So when we're comparing the impulse of one object to another object, let's think about it in terms of Newton's third law. If you don't recall, you should know this for the test. Newton's third law says that if A pushes B, B pushes back on A with an equal and opposite force. And the way we would write this is, in this case, we have the force on a bullet due to the rifle, and what we're saying is that there's a force on the rifle because of the bullet that is equal and opposite. That's what Newton's third law says. So those are the forces. Now, the definition of impulse is that you multiply by time. So what this tells us is that when a rifle recoils from firing a bullet, the impulse that acts on the rifle should equal the impulse on the bullet. So now what we need to do is see which choice here matches that. So let's see. Is large compared? Nope. Is small compared? Is larger compared? Leaves the momentum unchanged? No. Momentum may be conserved, but that doesn't mean it doesn't change. So the answer, ironically, not ironically, but strangely, because we almost never have this as the answer, is E, none of these. All right. Now for 4 and 5, I'm just going to tell you something right now. All things being equal, bouncing almost always has greater momentum change than non-bouncing. But what I'm going to do here is we're going to do a little bit of algebra to prove that. So one ball bounces and another ball the same mass does not bounce when dropped. So dropped or thrown, I'm going to do a horizontal picture here just to make it clear. So let's send in the ball this way with a speed v0, and let's bounce it back with a speed v. Let's be clear though, we'll make this negative v since it's backwards, and this is mass m. So the change in momentum is going to be mv0 minus, negative mv minus mv0. And let's do a little factoring here. That's going to give us negative m v plus v0 when we factor. Now we're looking for the size of this, so let's take the absolute value of it. So we have a net momentum change of mv plus v0, which is the same as the impulse. Let's compare that now to something that hits and sticks. So it sticks here, so what we're going to end up getting for our change in momentum there is we're going to get 0 minus mv0, which is negative mv0. So the size of that momentum change is just plain old mv0. So clearly, the ball that bounces has a greater change in momentum, which means it has a greater impulse, which means both A and B are true. Next. Which of the following differs the greatest impulse? A lump of clay that sticks to the wall or a lump of clay that bounces? Based on the answer to 4, we can also say that bouncing always gives you the bigger change in momentum. So that's kind of if you don't like this math, what I would memorize is that something that bounces gives you a greater momentum change and therefore a greater impulse than something that does not bounce. All right, lastly, an egg hits concrete and breaks. Another egg dropped from the same height hits a trampoline and bounces back at the original speed. Once again, even in a strange case like this, let's actually go with this truth. Bouncing is bigger than non-bouncing. So strangely, C is the correct answer, but let's talk about it in terms of intuition. So let's have one egg it falls, it hits the concrete, and it breaks, right? So we have eggshell, and we have this kind of spilled yolk, gross, and we have like egg all over the place, yuck. Okay, that's fine, but let's note, we have it hitting the ground, so let's just be clear. The speed right before it hit the ground was v, and then when it hits the ground, the speed equals 0. So v naught goes to a final v of 0 versus the trampoline egg that even though it hits the thing at v naught, it bounces at v and doesn't break. So what's actually happening there is you still have the bigger change in momentum. Let's be clear here. Yes, there is a bigger force here, but it acts for a very small time. Here, we have a small force acting over a much, much, much larger time, so much larger that this small force over a large time gives you a bigger impulse. It's a bigger, the way I would say it is this. The bouncing egg has a larger, gentler impulse. All right, so that's the second page of the exam.